Hi again. It's me. I'm back again. My name's Megan. I was hosting the last panel if you weren't here and you're just wondering why I'm so chipper. I am here today and I'm going to have a very interesting conversation with this wonderful panel of experts who are going to discuss the topic of biodegradation and circularity. We're going to be discussing how fashion can look to nature and natural systems to support the emergence of the circular economy. There's a really great exhibition in the hall, and it kind of explains this issue really beautifully. And it looks at the fact that the reality is that not everything will eventually become waste. Not everything can live in a circular loop forever, and so within that circular system, once something has been used again and again and again, we do need to find a way to bring it to the end of its life. So harnessing biodegradation and returning materials to the earth in an ecologically beneficial way holds really great potential for creating a more holistic circular system. But first, before we get to that, we have to understand really what biodegradation means, how it can be embedded into the design phase, and the impacts of finishes and dyes that can have on this process as well. So I really encourage you to go check out that exhibition after our panel, and during the conversation today you can also ask questions using the QR code, and I will try and get to them at the end of the conversation as well. So, to introduce my panel, today I am joined by Dr. Amanda Parks from Mothership Materials, Kelly Sheridan from the Microfibre Consortium, Friederike Von Wedel-Parlow from Beneficial Design Institute. Sorry, Friederike, you have a tricky name for this time of the afternoon.
Yeah. So sorry.
And Amanda Sturgeon from the Biomimicry Institute. So welcome everybody. Thank you for joining us. I'd like to start with you, Amanda Parks. Mothership Materials exists, in its own words, to solve a $4 trillion feedstock problem in biomanufacturing. Can you share a little bit of context with us around what's going on in this ecosystem at the moment and the kind of why of Mothership Materials?
Absolutely. So some of you might know me from my past life where I was the founding scientist and chief innovation officer at Pangaea. And when we were developing many different new materials, project collaborations, co-development, one of the things that always was coming up was really about how these technologies can scale and the cost of them scaling, right? And we just could never, there was some fundamental things that were blocking it, and almost everything, as I went out to the kind of edges of the research, it was all upstream in the processing and getting all of the bio inputs and feedstocks that we need to be able to make all of these wonderful bio-based materials that we now have the technology and the innovation to do. So Mothership Materials, which is my new company where I'm the CTO, we are doing molecular separation of agricultural waste across different domains. So we can do things like banana and pineapple and bamboo, but we can also do brewer spent grain, or we're kind of agnostic in what we put in. And it's a technology that doesn't use chemistry, it uses biology and physics, sonication, centrifuging, and a new biological capture particle innovation. So the point is that the feedstocks, which we primarily are making glucose and cellulose right now, the glucose industry itself, just selling glucose for biofabrication and precision fermentation companies to make new materials or to grow anything, to literally make drugs. Microbes are the future of a lot of manufacturing. This is what we're doing. We're enabling that to happen. So separation, our engineering systems have taught us lots of ways to build things up, and we don't have a lot of innovation to break them down. I mean, in this room we do, but generally in this world. So that's what we're trying to do, get everything back to a molecular feedstock.
Very interesting. And I think that's something we're going to explore today in this conversation, is how we can look to systems outside of fashion, bring those systems in, and then I think in a way find solutions and find products that we can create that don't exist in the fashion system, taking textile waste and turning them into other things as well. But we'll get to that. So I'd like to take it over to Amanda Sturgeon. The Biomimicry Institute has done some really fascinating work on exploring how nature can be a guiding principle for fashion. Can you talk us through first that topic, and then also how we determine biodegradation and how we can learn from what nature is doing in the biodegradation process to materials?
Yeah, absolutely. So biomimicry, for those of you that don't know, is a practice by which we look to nature's genius and brilliance and understand both the biology, the chemistry, or the systemic sort of strategies and functions that happen in nature, and look to see how we can inform innovation or new ideas or new relationships that we make based on the 3.8 billion years of evolution that nature has ahead of us. So in this project, in terms of fashion, I mean, we just heard Amanda talk about breaking things down. I mean, nature, there is no such thing as waste. Any sort of set of structured products, if you like, in nature are always reused as nutrients. And that will happen through sort of microbial conversion into the base elements, typically CO2, water, and some kind of biomass, that nothing remains. And as Amanda was talking about, that's an enormous challenge in the fashion textile sector, because we don't have the ability to use often nature's basic decomposition building blocks, sun, plants, bacteria, microbes, fungi, would all be present in nature to break down anything as it reaches the end of its life. So what we're looking to nature for is that how can those principles, bacteria, microbes, fungi, etc., be mimicked, if you like, in biodegrading end-of-life fashion waste. And as I'm sure everyone in this room already knows, it's an enormous supply that we have of end-of-life fashion waste. So hopefully, ideally, we would be recycling and reusing, but given the quality now of so much fashion waste, its end of life is coming even sooner. So, we think that decomposition or biodegradation, I can never say biodegradation, is one set of solutions that the circularity system is currently missing right now. So once you get end of life, what happens? Currently a lot of incineration, but as we'll talk about maybe in a bit, there's regulations coming in to start limiting that. So how can we look to nature's principles to help us biodegrade these sorts of end-of-life garments, textiles? So yeah, there's various different processes. I'm sure Friederike is and Beneficial Design Institute, as well as Circular Economy and Ore Foundation, are partners in our project called The Nature of Fashion. And I know Friederike will tell you a lot more about it in terms of what we're finding as we're piloting, mimicking some of nature's systems to see what the limitations are of the system to mimic nature.
Thank you very much. Kelly, I'd like to bring it over to you. There's an obvious question here around synthetics and what impact that has. The Microfibre Consortium is part of a study that was released earlier this year that explored the impact of both natural and synthetic materials on the environment, and I think there were some really interesting takeaways from that study. Can you tell us a little bit about how chemicals and dye inputs can impact the biodegradation process of both synthetics and naturals?
A little bit about, can you hear me?
Not very well, a little bit.
No?
Keep going.
The Microfibre Consortium, for those of you who don't know, are a science-led, non-profit organisation working right across the textile supply chain to develop practical tools and solutions to mitigate fibre fragment pollution to the natural environment. And one of those solutions that is often put forward is biodegradation. If we have materials that biodegrade, typically natural materials, then we don't really have a problem. And so from our point of view, it's really important to understand firstly, well, what's actually in the environment. And if we take a sample from the environment, regardless of what that environment is, be it freshwater sample, an ocean sample, even a soil sample, contrary to popular belief, what you will find is over 60 to 70%, sometimes higher, of all of those fibre fragments in that environment will be dyed cotton. Our oceans are not dominated by synthetic fibres, they're actually cotton fibres. So the question then becomes, why are they so dominant? What's causing this? Part of that is the materials from which they come from. They're shed from our clothing, they're shed during manufacturing, and they end up in our environment. So, and generally, fabrics that are made from natural fibers, because of their inherent nature, will tend to shed more easily. But then if they're natural, why are they not just biodegrading in the environment? And so one of the studies we were recently involved in, based in the UK, was to take a sample of the bottom of a lake in Middle England, next to an area that contained a mill years ago. And essentially there was a core that was placed right in the ground and removed. And what we were able to do was to section it, section by section, and whatever was present at the bottom is older, and whatever is present at the top is obviously more recent. And the bottom was dominated by cotton fibers. And as we started to get to the top, the mix changed and synthetic fibers started to become not more prevalent, but there was more of them. And then we dated back the soil, back to the 1800s. So when we talk about degradation of natural fibers, that's actually not what's going on. And so the next question is, well, why is that not going on? And the key to that is the fiber that is in your clothing, that cotton fiber, that wool fiber, that silk fiber, that is from a natural source. By the time it ends up in your clothing, it's no longer in its natural state. It's become processed. So even taking cotton from a plant, by the time you process it into just making it fibrous, you've changed the polymer structure from a cellulose 1 to a cellulose 2, and that is a foreigner to the environment. Then on top of that, we add chemicals to it. We had different finishes to it. And so in nature, that cotton fiber is not treated in the same manner as a raw cotton fiber. So at this present time, using the chemicals and finishes that we have been doing is not encouraging biodegradation.
Can you talk to us as well about the difference between a finished garment and how that might react compared to raw material in that biodegradation process as well?
It's simply because if you take a cotton plant, just as Amanda was saying earlier, it's completely natural. If the ball from the cotton plant falls off into the ground, it biodegrades really easily. It's raw. It's recognized by the environment. But by the time that has been processed with added chemicals, it's just changing its nature, and that becomes harder to break down. It may be easier to break down than a synthetic fiber, for sure. But the question is, how long does that process take, and what damage are those fibers doing in the meantime?
Yeah, and I imagine there are a lot of misconceptions around this because, I think potentially in reaction to that report as well, people would have just thought, well, it's a cotton t-shirt, why can't it?
And recently, I just read, I think it was last week actually, maybe the week before, there was a wool garment found in the depths of the ocean, dating back, decades, that was completely untouched. So it's not just the material itself, it's also the environment in which these things are found. Yeah. So if I give you a simple example that we can all relate to, if you buy some strawberries from the store, you want to store them in the fridge because they last longer. You leave them on the bench, they go off quicker. The same is true for where fibers end up in the environment. If they're in the deepest depths of the ocean where there's no light, there's no oxygen, they take longer. They will stay there. They don't have the means by which what nature requires in order for them to biodegrade.
And it sounds like at the moment, those industrial processes that are necessary if we're going to talk about biodegradation at scale just don't really exist in the way that we need them to. So it's like all of these structural issues as well. Friederike, I'd like to bring it over to you to talk about the work that you've been doing at the Beneficial Design Institute, looking at this intersection of art and science. We've kind of mentioned already that it's really necessary for designers and brands to be able to take these learnings and implement them into a product design so that we can start to create that circularity from the very top of that chain. But, there's a lot of considerations, obviously, that come into that. Can you talk to us about how a designer can adopt ideas of biodegradation and do that in a really efficient way as well?
Yeah. Thank you very much for having me in this conversation. So at the Beneficial Design Institute, we're doing design research and development and consulting companies to design for the biosphere. And since 3 years, we're so happy to be part of the initiative by the Biomimicry Institute. What we did before working together, we rather kind of started design for the biosphere, so bringing all the right elements together with the purpose of products that would hopefully have not these issues, but where all components are selected and evaluated by their molecular level if they impact the health of the planet and the people in kind of either neutral or positive, and that you fade out everything you would not know, and you fade out kind of everything where you know it's critical, and so kind of on the highest level you have only where you are aware of the impact. So this is the kind of the cradle-to-cradle system in which we kind of work to design on this molecular level. We always have a bit the issue of how to define biodegradation, and there are some D norms for that, but it's for packaging. And this is totally misleading because a tree, a plant, cotton would never fall under this D norm. A tree is simply not biodegradable if we just get that understanding of it. Because that's it says that after 90 days of degradation process, you would not see 90%. Like it's so small particles, so you could not see it. But these chemicals, these tricky ones, the microparticles, you would not see them. They were still there, and they still last, and they still kind of poison wherever. So it is everywhere. So this is really a misleading definition. While looking into a plant, how it's built by photosynthesis, and carbon is built into the tree, and after the tree, I mean, a tree in the water, down the water, would also be there for ages if there's no light, and it like next to the wool pullover, and would not fall. But if it fall off, it's just carbon and water again, like at the start of it. And this is so amazing in this kind of process that we are trying in the northern pilots, more on the industrial level, I would say. In the global south, it's really more the direct biodegradation of the material, is that we look into breakdown principles, or learn from nature how to break down back to the molecular level with, for example, enzymatic hydrolysis, or also with polyester hydrolysis that can separate to the monomers that build PET, for example. And then you take these and rebuild it together to new material, and then take the wisdom of algae and bacteria to ferment these into new materials that are then biopolymers with similar properties as polypropylene, for example, but they're similar as a tree as well. So when they degrade, they fall back into carbon and water, and this is really magic. I think I would never have thought so, how much the learning of nature here really comes together. And then you have spun yarn, you have 3D print material, you can injection mold it, you can make foils from it. It's still kind of initial, and having this, maybe I should also say, we are taking actually in that the end of the, so at the end of the supply chain, we look into textile waste, especially the most critical one, this that goes today into incineration and landfill, and try to tackle that today is by its nature, it's so complex, unseparatable, kind of dirty feedstock, and to use these technologies and broaden the technology to also scope these ones, and then make glucose, for example, again, and bring it back into these cycles. And they're having the breakdown and the build-up process as nature would do. But in technical processes, and biotechnological processes.
It's very interesting. It's also extremely complicated. I think one thing I'd love to understand, and I'd like to open this up to everybody as well, is how you would describe or how you would educate someone who's within a brand wanting to understand, how they can implement this. I think maybe there would be a conception that you could only use linen or hemp or undyed, untreated fabrics, and then from a brand perspective, that's just not enough creativity. That's not enough. That doesn't give them enough to work with. So how do we kind of in the last panel we were talking about bringing brands in and getting them to really buy into these innovations so that we can pull them through the supply chain and we can actually make them a reality. But from your own experiences, like how do you engage brands in this idea and how do you educate them on what this really looks like? Amanda, Sturgeon, would you like to start?
Yeah, I could start. I would say it's difficult because the concept of waste is not a popular topic, firstly.
Yeah.
So I think, the waste is kind of out of sight, out of mind. It's getting shipped down to places like Ghana, where we have our partner, the Ore Foundation, and those that consume the clothes in Europe don't really have to think about it. They're not really putting pressure on brands, obviously, to change. And so it's been difficult, but we are starting to make some headway saying that. We've been persistent in the Nature of Fashion project, and we're starting to get some sort of interaction with brands where we can bring them the amazing scientific green chemistry knowledge that Friederike just gave a little window into, and ask them for their thoughts. How could we collaborate around this? What kind of information do you need to know that would help you think about different types of fabrics in the supply end? If you know the chemistry of what can break down, how do we translate that into supply? And so we're starting to have those conversations about what might work for them, what kind of research they're looking at, and so I would say it's early, from our perspective. Yeah.
Would you like to add something?
Yeah, I'll jump in. I think it's maybe a little bit less on the education piece, but I want to first follow up on what you said, because in my head I did sort of a provocation when you say, okay, so if something is like untreated, undyed cotton, and there is particulate that ends up in soil or in the ocean, what kind of damage is that going to do to the ecosystem versus what a synthetic does? And I think this is a really interesting, nuanced point. And I want to keep that conversation going a little bit. And I think that's what I first would love to hear from you about that, because that's one of those things that gets battened around. And I understand the difference about changing the structure, but does it actually matter if it's in the environment, right? Like, how does that actually change how we're living with nature? That full cycle. Is kind of like one of those further places I want to go to. And then the other thing, reacting to the brands, I know this being kind of inside a brand and also being on the innovation side, one of the hardest things to get in our industry is reliable biodegradability testing and all different methods, and it's super expensive. And so we're right now working with the state and city of New York, and New York is actually becoming like a biotech materials hub. It's great. And they're planning all these labs, et cetera, and they're like, oh, we're going to have scanning electron microscopy for characterization, all this. And I'm like, we need a biodegradability center. We need and it's like, it was shocking to them. And I'm like, if the material producers could have more reliable tests and also methods that can accelerate them, so simulations, et cetera. There's some work in AI going on around that. That's really important. But really, we don't fully understand what does actually happen to all these new innovations. And so this idea of testing, to me, is making that accessible and making that just as easy as you would do like a strength test or abrasion or anything, just making that a kind of an essential part of the loop for the brands and making those visuals. And I also think that the metrics are also kind of underexplored in terms of it's like a black and white. Either it's biodegradable or it's not because of this one test around 90 days. There's so many layers of gray that are so important, which goes back to my point about, well, does it matter if it's in the bottom of the ocean? If it's not giving us cancer and it's not killing the fish or the microbes, does it matter? And that's I think where that conversation needs to go next. So, and I also, as a scientist, I'm like, I'm not actually sure how much it matters, right? These are the It matters if there's a giant landfill of something and you've totally changed the characterization of the soil, but where's that line around what we're actually changing, and what is the natural built environment, I think is what we're saying.
That's a really interesting point. Would you like to expand on that?
Yeah, sure. I think it's fair to say that the science is catching up. Most of the research that's been done to date is focused on polyester fibers, synthetic fibers, because of the understanding that the oceans are dominated by microplastic fibers. And so the scientists are keen to understand, well, what impact do they have? There's recently the academic community are now recognizing that they need to look beyond just synthetic fibers, and so there are some really great studies that have come through that have compared the two types of fibers. If anybody's really interested, Suzanne Brander's work from Oregon State University is really interesting. She's just moved to Pew Charitable Trust. But she was one of the first who actually looked at the effect of cotton fibers versus polyester fibers. And what she actually found is it's a combination of the physical shape of the fiber plus the type of fiber itself. So there are negative effects that cotton fibers impose, such as organisms have a shorter life, their reproduction system's affected. And ultimately all that has is an effect on our driving down biodiversity and having a negative effect across there. But what we don't really know, and to your point, is what is it about those fibers that are having this effect? Because we can't, what we haven't done at the moment is being able to break down the chemicals from the fiber. Yeah. It's not for the industry. It's not enough just to go and buy a cotton t-shirt from the store and a polyester fleece from the store and then analyze them. It's really great because it's a start, but we need to really understand at which stages across the manufacturing process is having the greatest effect. And the truth is we don't know. Yeah, we just don't know because we're still a little behind in the polyester space. And I was just going to ask something else there, but it's escaped me. No, I'll leave it there. If I remember, I'll come back.
We'll come back to
yes,
you. No problem.
It's a really important point, and I completely echo your point about the need for a suitable standard for biodegradability. I think that's a real challenge when new solutions are being found with a certification or a standard of we have tested this and it biodegrades. My question is always, at what point have you tested it? Because if you tested it as a fiber, when you've just developed it as a polymer and not when it's in a finished product, they're not the same thing. So there's a whole conversation to be had about how we measure biodegradability.
Yeah. It's the most unsexy topic that there is. Like
it's
literally
sexy.
No one wants to pay for
100 odd people who
in this
sexy.
room, but like you're trying to get brands to spend money on
right, Anyone from a brand that wants to spend money, put your hand up.
It's like literally just the cycle of the test is like goes through like 3 or 4 seasons of a brand. So it's like the time metrics are totally off.
Yeah, and that's definitely something we talked about in the last conversation was the fundamental cycles of what a brand is doing and what an innovator is doing and research, and they're all moving at different paces. So it can be very tricky, and it does really sound like there's not enough research happening, and there is need for specific research labs to be able to do this, and there's so much potential there for great benefits to come out of that as well.
And that's the opportunity for brands to get involved with it. It needs to be relevant research. Research for research's sake doesn't often help anybody. It needs to be relevant so that the key learnings can be drawn and then implemented.
Yeah. I'd like to talk about one thing that we touched on in the beginning of the conversation, and Friederike, you mentioned something really beautiful in our kind of discussions leading up to this panel around moving from circularity to a spherical system. And part of that is taking textile waste and turning it into stuff that isn't textiles and hasn't got applications within the fashion industry. Can you talk a little bit more about that? And then I'll open it up to both the Amandas as well if you want to chime in on that one.
Yeah, I think we are in the circularity discussion since so many years, and there was this tendency to prefer the technical cycle because it felt like there is something you could endlessly cycle and it's somehow more easy to steer and to control. And the complexity of the biosphere is something that has not been tapped into. And it's very important discussions, but we can feel, okay, there is this complexity. I think there's something really to embrace also from a company level, that we have here not a cycle. So it's not about not only a cycle, like a line in a cycle where we focus on textile to textile recycling, as this is where we need to go. This is one way to go, because we come from bottles to textile, which obviously is a mistake in system, because the PET cycles perfectly in bottles, and it should not go into textile where the abrasion goes everywhere and has the effects we just heard. But looking into the biosphere, we have this cascade, and we have the higher, super beautiful quality in the beginning, and the cycles tend to break down. And we understood this in the past as something negative, as a mistake of nature. But it's something very beautiful, where we can just steer that we make first a T-shirt, and we can mechanically recycle to next one, and maybe 3 times, I don't know. Then we are maybe at an end of this kind of recycling. But at the lower bottom, we can chemically recycle and respin the cellulose. But also at a certain point, the cellulose is too short chain, or I don't know if that's a perfect technical description. But then we can turn it into glucose and turn it into this biopolymers, for example, with the ability to biodegrade or to metabolize. That's a term that's kind of falling into carbon and water. And then we can bring it into other markets as well. So it's rather open loop system. And if we see this all more as a sphere where material comes in certain cycles into the one sphere and the one industry, and then it's perfect for the other one, I think we could make really great benefit from owning these materials and blending it for a certain time to a certain industry, taking it back and sharing it with nature again, and then doing these products which are designed for leaving, where they are like geotextiles, for example. We maybe want to have them for 1-2 years until the roots are growing, and then we would love to be away of this, away carbon, water, and not having all these microparticles everywhere. So I think there is such a beauty in nature that we should learn and have a much risk these and value the stairs instead of avoiding it, collaborating between industries.
And I want to follow up on this the metaphor of nature. Like, nature doesn't differentiate between industries, and to bring it into the real world business case, where the economics make a lot more sense if you go cross industry. Our business model is dependent on that, and the entirety of like fashion has this way of being so insular, and it sort of is like an easier story to tell, like textile to textile, but it doesn't really make sense in nature. And so even just what we're doing, where we're taking agricultural waste that was a food crop, and then we're returning a rev share to the farmer based on, we're making other molecules, right, that can then be sold off. That's literally the definition of having multiple side streams is how we actually create value and the economics of any of these things working, because we're not just taking one molecule from it. So a business case, that is another reason. It's harder, of course, but in terms of the finances, it has to happen to make a lot of these companies work.
Right. Did you want to add anything, Amanda?
Yeah, well, I think just to reiterate, we see a lot of crossover. We also at the Bioinker Institute have a innovation accelerator, and we actually see a lot of crossover between like textiles and buildings, or vice versa. So you break down construction waste with mycelium or fungi-based systems, and spin out something that perhaps the textile industry could use or the building sector could use. So we often see a real crossover as well as into agriculture as well. And I think we have to be pretty versatile across sectors in order to be able to make this work. We know we've got in fashion an absolute glut of supply in terms of waste fashion. There are multiple sectors that are looking for these materials as they break down to recreate new materials. So yes, I think it's been a learning for us in the pilots to sort of come to that conclusion that it's not just the fashion to fashion cycle.
Because we're in Brussels, I thought we can't really have this conversation without talking about legislation. Is biodegradation covered in legislation currently? Where do you think it should be added into different pieces of legislation? Do we need to have dedicated legislation around this? Maybe I'll start with Amanda Parks and we'll go down the line and you can share your thoughts.
Okay. I'm by no means an expert on legislation, especially not really European ones, but I can definitely say that one of the things about using waste in general and the things that we produce, it's very important for the glucose that we make in terms of decarbonizing. So what you'll see is, when people are trying to do life cycle assessment and everything about assessing their company, tier 3 is always the thing that's most we don't know. And so having inputs that are waste generated is at least a first step to that decarbonization cycle, which now, of course, means money. It's better for your company. So I think that's one of the first places where we can start to think, hey, this is just switching what you said, nature has no waste, this is a valuable input, and suddenly our business model makes more sense. And then I just want to harp on about the testing. If we had more facilities and it's sponsored by government labs to be able to do that, then I do think that having more of a range of, I don't want to say certification because I'm not pro certification, a lot of it becomes financial and political, but having a lot, just different categories of what actually is happening, and that is some ways systematized to understand that it's not so black and white. I think that would be very good use of government structure.
Kelly?
In the latest milestone, the third milestone of the ESPR that was released from the JRC, biodegradation is in there. But the feedback that we provided is that it's not harmonized. We need a really harmonized definition, firstly, of what biodegradation means. And then furthermore, again, just echoing what Amanda's thoughts are, we need to be really clear on what methods can be used to measure biodegradation, because until that is standardized, it's a complete mess. So it's in there, but it needs some work. Otherwise, it's just going to send everybody off in the wrong direction.
I'm fully with the need for some kind of standard and definition on what is that exactly. In addition, I think it's all these processes that you're working with, or that we can see also here at the fair, that we need also to add these biotechnological recycling processes to the mechanical and the chemical, but have the biotechnological processes as well as a perspective that need a frame, that need somehow harmonization, understanding, definition, and so on. But so to really integrate that into the legislation. In Germany, we are in the EPR discussion now on how to put this into eco-modulation and so on. But I think these could be places where we need to acknowledge that some new processes are growing and that they need to have some relevant space in there as well. And in addition, there's also the bioeconomy strategies, and I think they run somehow totally aside of textile industry. And I think there could be some more integration or learning or crisscross to the textile strategy or circular strategy.
Right.
Yeah, I would just say, I mean, obviously EPR and ESPR are groundbreaking, policies to address waste. I think now the question is, how are they implemented? What does that look like? And for us, I think in the biodegradation space, the research that our pilots have done, we've heard about the need for research, has been funded by philanthropy through Loudis Foundation predominantly. And, really what I would love to see is, as a result of these policies requiring brands to sort of pay to address the waste, for some of that funding to go into establishing the infrastructure for biodegradation facilities in Europe before the waste that really can't be resold gets shipped to Africa, in our case Ghana, and just gets dumped into the ecosystem. So, we would love to see some funding coming out of it. I think that's the key thing. How can the funds that get accumulated actually go into some biodegradation infrastructure, because we know it's not the only solution to this enormous waste problem, but we think it's a pretty significant one. And without the investment in the infrastructure before this waste leaves the country of source, it's difficult to do it on a shoestring with philanthropy, frankly.
Yeah.
Just one thing to add. I also think we have a comms problem, right? So in New York, we have the Department of Sanitation. It's a horrible name. It covers everything about, yes, of course, trash pickup and wastewater treatment, but recycling and composting. And, what if it's renamed the Department of Secondary Resources, or even the Department of biodegradation? And so to think about like how we talk about what this material is I think another place where government could start.
Yeah, and I think just to add, I mean, we think that these facilities could ultimately be profitable.
Yeah. Oh, yeah.
Because they're creating new resources out of things.
Yeah, exactly.
That once they're broken down, but they need the initial investment to sort of get them established. So, yeah.
We've got time for, I think, probably one question. And I've got an interesting one here that I think is, talking about this idea of potential around, we've learnt things from nature, and there's a lot to learn from nature, but what do we still need to embrace closer? What are the maybe elements of this conversation that are untapped, or you're looking at next as something that we can bring into this biodegradation conversation to really push the conversation further and really explore further? Who would like to take this one? Maybe Kelly, do you want to try?
I think just echoing what I heard from yesterday's panel on toxicity, that we need to design for end of life. I think there are solutions out there that can ensure that the dyes and chemicals that are being used in our processing at the moment can break down in a way that is unharmful. I think if we design in that process from the beginning, there's huge opportunity to do that. But we need to think of the end point when we're starting, rather than the other way around.
Maybe to add on this, to achieve that, I think it's also really necessary to work and think into building ecosystems in which we locally can build up from the waste to new materials, and then the material kind of to have local supply chains, but also local applications, and build these ecosystems to enable that flow and that kind of material health designed for nature, designed for this biosphere context.
I mean, I would love to see brands, and as I mentioned, it's starting for us in our project, step into the space and realize that this, waste isn't something, and biodegradation isn't something that they have to, sort of hide away from because it's bad for brand or whatever, but actually it's really good for brand because, it creates a whole new realm of innovation and supply chain, and to really step into the space and help with the research and pilot the research and help sort of build the whole industry and move it forward.
I think that's a really lovely place to finish up. Sorry, I think we're out of time. Thank you so much to my panel for your insights. I would really recommend everyone checks out the exhibition. It's kind of like that direction. There's a lot of really good information there. So if we can give a round of applause to our excellent panel for this afternoon. Thank you so much, everybody.
Thank you.